AI learns from us, from our books, our websites, our history, our decisions. And that's exactly the problem. Because when a model learns from human data, it doesn't just pick up our knowledge. It also picks up our blind spots, our stereotypes, and our unfairness. Today we talk about bias in AI, why it happens, where it does real harm, and what we can actually do about it. Welcome back to AI in 5. Let's start with the core idea. A model is a mirror of the data it learned from. If that data reflects an unfair world, the model will reflect it right back. We sometimes call this bias in, bias out. The machine isn't choosing to be unfair. It's faithfully copying patterns it found in the examples, including the patterns we wish weren't there. Here's the pipeline. Human decisions and writing, across decades, become the training data. The model studies that data and soaks up its patterns. Then, when it makes predictions, it repeats those patterns. So if, historically, certain jobs were mostly held by one group, the model may quietly learn to associate that job with that group and treat it as just the way things are. The bias rode in on the data. This isn't just a theoretical worry. It shows up in high-stakes places, hiring tools that quietly favor some names or backgrounds over others, lending models that offer worse terms to certain groups, risk scores used in courts, health tools that work better for some populations than others. When a biased system touches real lives at scale, the harm is real, and it can be hard to even notice. And here's what makes AI bias especially serious. Scale. A single biased human reviewer affects the people they personally meet. A single biased model can make millions of decisions, instantly, everywhere, all with the same slant. So a flaw that might have been small and local gets copy-pasted across an entire system. Automation doesn't just speed up good decisions. It speeds up bad ones too. There's a comforting myth we need to kill. People assume that because it's a computer doing math, it must be objective and neutral. But neutral hardware running on biased data gives you biased results, dressed up in the appearance of cold, hard objectivity. That false sense of fairness is actually dangerous because it makes people trust an unfair decision more, not less. The math can hide the bias, not remove it. So how do we deal with it? The first rule is, you cannot just assume a system is fair. Fairness has to be measured, on purpose. That means testing how the model performs across different groups of people, and specifically looking at who it gets wrong and how often. If you only check the overall average, you can completely miss that it's quietly failing one group while acing another. From there, the toolkit is practical. Use better, more representative training data. Run independent audits to catch problems before launch and keep checking after. Keep a human in the loop for decisions that seriously affect people, instead of fully automating them. And be honest and transparent about what a system can and can't do. None of these are magic, but together they make a real difference. And maybe the most important point, we can't let the algorithm become an excuse. When a model makes an unfair call, the responsibility doesn't vanish into the code. It belongs to the people and organizations who built it, chose the data, and deployed it. The computer said so is not an acceptable answer. Humans stay accountable, full stop. So bias in AI is real, it's inherited from us, and it scales fast, but it is not hopeless. With careful data, honest testing, and human oversight, we can build systems that are fairer than what came before. It takes intention. Tomorrow, we shift to something more creative and a little mind-bending, generative AI, the tech that conjures brand new images, audio, and video. See you tomorrow on AI in 5.